a stone has dropped down a disused mine shaft and takes 3.5 seconds to reach the bottom. How deep is the shaft? And how fast is the stone going at the bottom? Yeah, it's a legit sort of question. Something that we all do at some stage. Chuck something and see how far it's going. Rightio. So same thing we did before. First thing is check the units. So any problem with any of the units in there? I've only given you one unit, seconds. It's the unit we said we should be in, so the unit seems to be legit at this stage. Okay, we need 3 things. So what 3 things do we have here? Logan? Initial velocity. So what's the initial velocity? Okay, so when we're talking about dropping something, we'll sometimes see language that says things like starting from rest. Okay? That's code for initial velocity equals 0. Okay, so sometimes there doesn't seem to be enough numbers, like there's only one number here. You're thinking, where's the rest of the information? So phrases like starting from rest or dropped means initial velocity is 0. Okay? Just before it lands. Yeah. So when I say how fast is it going at the bottom, the answer isn't 0. The answer is, if you're standing at the bottom thinking this is going to hit me, it's not going to hit you at 0, is it? No. So it's doing something. You want to know what it's doing just before it hits you on the top of your head. Yeah. Okay. So Logan, you said initial velocity in time, which is 3.5 seconds. Cool. I need 3 things. What's the 3rd thing? Yeah. Acceleration. And what's acceleration in this case? Okay, because it's been accelerated by gravity. Okay, so when you have a situation where gravity is doing the job, then the acceleration is going to be 9.81. If it's speeding it up, if it's slowing it down, maybe negative 9.81. But I'll do an example like that shortly. Okay, so we now have our 3 things, which is great. What are we trying to find? How deep is the shaft? Okay, so we're trying to find, for the first bit, we're trying to find S, and for the second bit, we're trying to find how fast it's going at the bottom. Okay, so which formula do you want to use for the S bit? Okay, it makes sense to me. Yep, okay, so Nathan selected this formula. It's got U, T, and A that we know, and S that we're trying to find. So that looks like a fine formula. And another one where we don't have to rearrange anything. There's already S equals, so that was easy. So we can substitute in the values. So S equals U times T plus 1/2 times A times T squared. Grab the calculator, and the answer comes out to be, who's done it? Like it looks like he's done it with the calculator, no? 60 metres pretty much. Do you want to give us, let's say, at least one decimal place? 60.08, that is pretty 60, so let's call it 60.1. More than enough distance to accelerate the car. Yep, so again, it's exactly the same process. Check out the 3 things you've got. What do I need? Formula, rearrange, values in, answer. Let's do the second half of the same question. So now we want to find V. So which formula do you want to use to find V in this situation? V squared equals U squared plus 2AS. Okay, so that's a formula that should work. We've got U, A, and S, and we're trying to find V. Have to rearrange that one though, because it's not V equals, it's V squared equals. Yep, so V equals square root U squared plus 2AS. Sticking some numbers in, square root of what's U? 0 plus 2 times A times S. Push the buttons on the calculator, and we come up with, not just random buttons, push the relevant buttons on. Got an answer here? 34.3. It looked like you were busting to say something before, Ewan. What was it? Yeah. So what are you trying to mix it up? I agree. I think there's two reasons why I would, in this case, prefer to use the top formula. What's the first reason, Ewan? Right. So the first formula is just, it's simpler to use, isn't it? Okay, because U is 0 and A is 9.81, time is 3.5, and that comes out to be, yep. So it's a much simpler formula to use. You don't have to do the rearrangement step, which is always a bonus. The other reason I'd choose to use that one is that it uses the things I was given originally. So with this problem, if I'd stuffed up in here and made a mistake, I'm then using that same number in here. And if it was wrong, I'd get the wrong answer again. Whereas here, I'm just going back to scratch, and I'm actually using the stuff I was given. And it's an easier formula. But it's good that the answer comes out the same both ways. Yeah. So at least what I'm telling you is consistent. It might be a lie, but it's a consistent lie, which is good. So yeah, often you have choice of which way you do it. Two things to consider: which is easier and which doesn't carry on mistakes you've made previously. Be my two criteria. Okay.